Das ist eins. Yeah. So I would like to spread some distributed log logic ideas that I have in my mind and that I came up during a presentation that I gave a couple of weeks ago. This talk is basically the gist of a talk that I gave in Helsinki 2 weeks ago about monitoring and basically log events, performance metrics, and inventory combined in a tool to just create more convenient dashboards for end users. So this is not really the topic of the meetup, I think. But I would like to extend this a little bit, and I will go through the slides or some slides to give you an idea. But I would like to extend this in a way where we can distribute the logic a little bit among the different clusters. So for me, it's HPC cluster, or in our case also AWS cluster, but it could also be just a bunch of containers on your laptop or what have you. So yeah, maybe I just jump in. I have a slide about Docker. I think everyone knows Docker so far, right? We have containers, which are all basically just grouped processes. You can isolate them, or they're isolated by kernel namespaces, and you can resource constrain them with C groups. So that's basically the 101 on Docker in 2 sentences. And yeah, it will look like this. You have these different processes on your host. If you do PS on the host, you will see all processes. If you do PS in the container, then you only see the processes of your container. So this 1 minute intro to Docker. And I use Docker now, I think, for 2 years or so, or 1.5. Yeah. And I started it by the need to create an HPC stack on my laptop. So HPC stack would mean you have all the services you need, like DNS, DHCP and stuff, and logging and performance monitoring. And I started out with... If I ask what HPC is. Sorry, HPC, high performance computing. So think of weather forecast or crash test cluster. Yeah, sorry, HPC. Who is familiar with HPC? Cool. And the rest? Should I go elaborate more on HPC? I don't think so, right? So you have a bunch of computers, they want to dig into a big problem, so it's not a single task, which you can just distribute on a lot of computers. You want to let them work together, so this is basically HPC in different scales, obviously, but yeah. And so I want to put this HPC stack on my laptop, and I started with VirtualBox. In VirtualBox, you start four virtual machines, and then you are done, right? So I put it aside a couple of months, and then I stumbled upon Docker, and I said, okay, this might be a use case for Docker, so now I can start 20, 30, 30, whatever container amounts, and the laptop is still on and running. So this kind of a nice use case for Docker. And by implementing this little framework to create different services on my laptop, I created also a framework of to use logs and performance metrics and inventory data, and this is where we jump into, I guess. So QNIB monitoring. Currently, in most inventory or most monitoring systems, you cannot overlay metrics with events. You showed one slide where you have this metrics, like I don't know what metrics it was. Just a scalar, it's just logging, so just a logging content. Yeah, but you could imagine if you have this. If you have like network traffic and you want to overlay more context to it, then you might want to overlay events out of your logging system, so that you can see, okay, this peaks comes from this cron job that's just started and is visible in the logging infrastructure. And I use also inventory system, which is back-ended by a graph database to get more inventory data into this system as well. So not only overlay metrics with logs, but also include information about the inventory, and I will go on the details in a couple of slides. And just more human sentence would be that we have to, or that I would like to get the user's perspective also into this scope. So there are different kinds of users with different ages, different backgrounds. So if you create a dashboard for a system, for logging, for performance and inventory data, you might want to think about who is using it. So. Right, so if it's a youngster, then it's different from an experienced guy who says, get me away from this clicky bunty stuff, I want the command line back. So you have to think about this as well. So I start with a system that use metrics system, which is graphite based, so the graphite universe. A log event framework which uses ELK stack, so Elasticsearch log/Kibana. And for auto discovery of services and configuration, I use Consul, which is a cool tool. Who knows Consul? Right, perfect. So this is quite cool. For those of you who don't know Consul, next thing you're at home, then Google Consul. It's pretty cool. So Logstash looks like this. For those of you who know this is Kibana front end for Elasticsearch, and Logstash feeds into it. I have Grafana as a performance metrics dashboard. It is based on the graphite engine, and so you can easily graph a lot of graphs, which is Grafana. But what you could also do in Grafana is you can overlay events out of Elasticsearch to this graphs. So that's pretty nice. This is an HPC batch job, or so any other batch job would do as well. So I copy a file from one node to a couple of other nodes in a sequential manner. So this is the first node copying to the second node, and the first node copying to the third node. So this is basically the metrics that you see, and the vertical lines are events according to this job. So that's pretty simple. So there you see is an rsync to the first node, and if you hover over the other lines, you will get the same information. Or not the same, you will split information according to this metric. The inventory is fairly new. I created it a couple of months ago or weeks ago, I don't know. It's basically a graph database, which is Neo4j, where I push information about different scopes or different slices of my infrastructure. So this is, for instance, an InfiniBand network. So think about network in general. You have blue dots are switches, green dots are network cards, and the red dots are ports. And you have these different connections in between them. So this is an InfiniBand, it's a HPC interconnect. But yeah, for that matter, it could be Ethernet as well. And with Neo4j or graph databases in general, you have mostly cool query languages where you can ask questions like, give me all nodes in between these two nodes with this and this attributes, and this is pretty powerful to query. But not only for network topologies it's interesting. I created a little snippet that put software install based into the graph database as well. So you have information about the host again, which you can connect to the network graph, and then you have information about applications that are used and when they were installed. So this yellow dot is a software installation connection node, which displays discovered at. So let's assume that is the install date and last seen at. So if it's already or is still there, and if it's vanished, then this will be one. So that's kind of the prototype for my software infrastructure or inventory stack.
Do you capture the version number of the software, or just when it was installed?
Yeah, there's also a field on attribute of the version, and I think also the path and something like this. So it's I use OS Query for it. Who knows OS Query? It's from Facebook. That's pretty cool as well. So that's it's at Go. I think it's Go, right? Is it Go? It's Go. I think it's Go. Must be Go because it's cool.
I think it's Go.
It's Go. Yeah, I think it's Go. It's a tool that you install, and then you can query some informations out of your system with SQL, with an SQL interface. So you can query, for instance, etc host. You can query which applications are installed. You can query which RPMs are installed, which depths are installed, and stuff like that. So it's a unique or interface, a generic interface for system information. It's pretty nice. And it's from Facebook, as I said. You have an interactive version where you can just do echo select asterisk from applications, and then you pipe it to OS Query I, which is the interactive version, and then you get an SQL output of all the application installed. And then there is a daemon where you can define queries to run, and if something changes in this query, only the change will be submitted to whatever you want to submit it to. That's kind of nice. So yeah.
This is more about the past, you know. This always looks so cool with 5 nodes, but after 3 years, there's hundreds.
Yeah, but
They've all
Neo4j.
changed, and
Yeah, but since it's
versioning is what about the past? The
yeah, you
versioning
could
is
if you run it a couple of times and over a long period of time, then you will build up a large history and a large information set of all the different slices of your infrastructure. Or what is your question?
And then you can use queries just to
Ah,
give you the
You mean
information.
you mean the OS query?
Yes.
If you have as soon as you have mobile software involved, you cannot stop it. And then you have not only 10 versions of this installed software does not go away. And this is all, what about changes? What about the past?
But if you install a new version, or if you then you will have a new node, and then this will be vanished, so this will be outdated, and then you query for only the active version.
How do you outdate mobile software? This is okay. You can't.
I mean, the thing is that when you track the whole history, you can specify the properties for this particular links. And then you can query what happened between May 2012 and 2013. Of course, when you say, give me all, this graph will not look nice, but it still gives you information that you can track and see how things are looking in history.
Yeah, and I mean this is a prototype. You can think of, if depending on your use case, you could create a date node, a separate node, and then link all the installations that are on a particular node to this on a particular day to this node, and then you can query a lot of more interesting queries. But this is just a basic query. So you have nodes, you have software, and you have the connection node that tells you when was it installed and when it was in the seed. So that's basic. It's just to show the one other use case than networks, because networks is basically graph databases, very keen of networks. And what I also put in the cluster is the SLURM, which is a batch control daemon, so that the user can tell, okay, I would like to run this job on 20 nodes, and then you submit it to the cluster, and SLURM will take care of the resource allocation and will schedule the job to the different nodes and get you the result back. Sorry. So this is basically the nodes are the red dots, and the jobs are the gray dots, and then you can link the nodes again to some other vector in your infrastructure. And if you combine all of the three informations, then you can see, okay, give me the job that was running on a node where this and that software was installed, which was connected to this switch, and you can all get this information out of the inventory. But that's I'm too elaborative on this topic because it's just the introduction. But what it's nice for the log event part of it is that you can refine stupid log, or let's say not stupid, but subjective logs to more objective ones. So for instance, we have this log from a daemon that assigns IP addresses. So this long number is a MAC address basically in the InfiniBand scope, and lit is the IP address. So you have a log that tells you something about an IP address assigned to a MAC address, which is not very convenient for a human to search for, right? You do not search for MAC addresses. But when you connect the logging system to the inventory system, you can look up the MAC address and then say, okay, this is port 1 of host something, and this is more convenient to search. And you could also add this information as a field, and then you can have some scripts active when this field is set to a specific value. So you have all the information combined. And it helps you visualize connections. So in the Ethernet world, you might have tools that show you how the network stuff is connected, but in InfiniBand you do not have this tool. So it's just the way, or just a way to visualize the network. It's the benefit for the HPC guys. But as I said, it's the introduction to the introduction. The introduction layer 2 would be the cluster use case. I just had some. This I can skip. The use case is a simple little SLURM cluster where I have a couple of nodes with a couple of groups and a couple of users, and I have two types of workloads. The stack is composed as this. There's a console container, so the blue boxes are containers. The red boxes are the service or the services that the container is for. So I have a console service in this backend daemon. I have some SLURM control daemons, so the master SLURM daemon, and some clients for the compute part. And I have a performance part where I have Graphite, Grafana, and Carbon. And I have also the log events part where I have all the Logstash and Kibana Elasticsearch containers and the inventory stack. So this is basically what's running on my laptop now, or was running on my laptop. And I created dashboards out of console templates. So this is just a dashboard that shows you the current network topology and shows you which job is running where. So all the different colors are different jobs, and blue dots are switches. And you can see which nodes are used by which users or by which group and how many jobs are in the queue. So that's basically just a simple dashboard for the manager to see if everything is fine and if the jobs are running. And this is also very helpful to see the placement of a job. So this would be a stupid placement because all the jobs, there are 2 jobs, they are running across multiple switches, which would be stupid to do because you have different hops between the nodes, and this will mess with your syncing state. But anyway, and if you click on one particular job, you can see the metric of network and maybe context switches, and you overlay this with log events. So here the MPI run starts, and at the end the job was finished, and you have the job map as well, but only with the job you are looking at. And this could be extended and extended and extended. Okay, so now the introduction is over. Questions so far? Too much information?
Have you mentioned so far InfiniBand, so you've run it on some kind of cluster, and you mentioned laptop. Have you ran it on AWS yet, or is it just kind of logging sort of like compute clusters and laptop processes?
Yeah, the background is InfiniBand. I used to work with a company that has InfiniBand clusters, and I still have some ties in this old LoF. So I ran this logging infrastructure also, or used to run it on InfiniBand clusters. But now I'm just mocking it up. So this is running on my laptop. There's no multiple nodes or something involved. But it's easy to distribute it on a bigger cluster. And we use the stack for our AWS infrastructure as well. And I think we will someday.
I was just thinking it would be pretty cool to see this running on like ECS or something like that, and being able to, if you're running like a HPC job across multiple ECS nodes.
I ran an HPC. So I did a study a couple of months ago. I presented it in March or so, where I ran an HPC workload within a container, and I ran it on different nodes. I ran it on my laptop. I ran it on my old gaming rig, which is pretty old, so it was the same speed as my laptop, which is something. Then I ran it on InfiniBand cluster, only on one node. I ran it on InfiniBand cluster with 8 nodes, and I ran it on AWS, which was pretty funny because the fastest in the C4 instance was quite new. So, and the C4 instance on one node was close to the same speed as an 8-node InfiniBand cluster, which says a lot about the InfiniBand cluster. It was an old one, but it was quite nice to see. And the C3 instance was, I think, was 20 minutes or so, and the C4 instance was 8 minutes, and the InfiniBand cluster was 7 minutes. So it was like, oh, okay. And the cluster was, I don't know, 50,000 or 20,000 euros or so. And I did it for €1. Anyway. Yeah, okay, so this is the level playing field, or not level, but this was where I came from. This presentation was normally an hour long. It's on YouTube. If you're looking for QNIB, you will find it somewhere. Google. Or I can give you the link. It's qualified networking with InfiniBand.
Is it a company?
And it's my last name is QNIB as well, but okay. Yeah, I have a side company, QNIB Solutions, but yeah. So from here, and then I talked, and then as I said, I was at a conference in Helsinki, and there was a guy talking about Fluent. Who knows Fluent? Who uses Fluent? If so, yeah, because I know Fluent as well, but I haven't used it yet. But it's as far as I understood it, it's basically just a multiplexer for messages where you can just submit a log or whatever message. Like here you have different inputs, and then Fluent will take care of filtering, buffering, or I think filter is just you have 3 filters or so. So it's pretty. If you think of Logstash filters, it's basically only 2 filters here. So maybe it's more about buffering and route. So you can submit, for instance, a log, and Fluent will route it through the Fluent cluster. And if in case there is some network problem or so, it will buffer it and then resubmit it. So it will take care of the distribution of the log. And then at the other end, you have different outputs where you can feed it into different systems. And for now, so as I spoke about all my QNIB terminal stuff, it's basically how I log. So I have a syslog ng daemon running in every instance, which is kind of overkill, I know, but that's how it is, because everyone knows how to syslog, so I use just a syslog daemon. And then every syslog daemon just forwards to Logstash, and then it's displayed and processed. For 3 containers, submitting stuff to 1 container, that might work, but if you have 40, 50, 100, 1000 containers, then it's kind of a bummer to have a central logging system, right? Because it will be overloaded. And furthermore, what is also ugly is if you create your own little fancy application and your own fancy little log format, then you syslog it, and then this raw information is forwarded to Logstash, and then you have to implement the logic behind your log format in Logstash, right? So every time you have another instance or with another application, you have to change Logstash according to what you're logging, right? You have to implement the logic. If it's like FTP server, then you want to act when the FTP server is down, so you have to add rules and you have to do stuff, right? So that's my problem.
This log output from Buffer, so now I need to change my Apache to.
Yeah, okay, this is maybe, I haven't thought about this, but then you have to tweak the tool that it's logging to sysout, right? To standard out or standard error, because otherwise it won't.
But why not use log forwarder in that case?
But the same, this log is basically a log forwarder in my.
Yeah, but
it's maybe more heavy.
I'm talking about log
forwarder
forwarder from, let's say, from the Logstash. Yeah? So the idea is that you can already filter the logs. And you will filter them not on the level of the Logstash as one central point, but you can have log forwarder for Apache, log forwarder for MySQLD, so it's much more reusable, I would say.
Yeah, but this thing is still not generic enough. Maybe that could be a solution, and I haven't thought about that. But I wanted to utilize Fluent. That's also,
Gotcha.
or I want to utilize it because I haven't looked at it yet. But I think how I would like to shape it in the future, that everyone has a Fluent daemon, and then they log to Fluent, and Fluent forwards it to Logstash. Mm-hmm. And since here is the inventory, not only this, but Logstash refines it and then pushes it back to Fluent, and if the inventory is interested, they can subscribe to some of the topics that are in the Fluent network. That's how I understood Fluent. Or is it consistent so far with your knowledge about Fluent? Perfect. But I think what I want is that I have a tiny little daemon that's running on each and every container or AWS instance or VM or whatever that is created by the guy who created the proc2 or the different processes, who knows about the logs and who has just a tiny configuration that is according to the process that he's running in. So proc1, if it's an Apache, then the qlog daemon should refine this log to a certain common sense JSON blob or common sense structure, that you extract the source host, that you extract which application it is from, and so that you create a kind of Logstash Lite version where you just structure the logs a little bit. And without having JRuby involved and all this fat stack that you need if you use Logstash. So I could start Logstash on each node, but this is kind of not what I want to do. I would like to have it a very small thing. Maybe it's Go, because Go could be compiled to a static binary, so you do not need any other stuff.
Log forwarder.
Yeah, log forwarder. I think I haven't looked at it once, but quite some time ago, and I'm not sure if you can all have all the grok magic in the log forwarder.
Yep.
Okay, so we can kick this out and put logs forwarder in, maybe. So this is basically then that you use the old, this should be the old message. So a log forwarder will get this message that I showed before, and then it spits out the refined message. It spits out some more fields to it to be able to send it to Fluent, and Fluent could distribute it according to the predefined or pre-refined logs. So if someone is interested in a log, which is not a stupid raw formatted log, but a more refined log, then he can subscribe to it and put it in his backend. For instance, if the inventory wants to know there is a new lit or a new IP address kind of assigned to something, then it could be forwarded to the inventory directly without the inventory having a stake, and I have to subscribe to Logstash and I have to look at Elasticsearch, so it will proactively get the information and can put it in the backend. So for Neo4j, inventory is Neo4j, for Logstash is Elasticsearch, they can be crossed as well. And this little daemon, and now that's where Logstash, log forwarder might fail. I would like to use the information from the backends as well to be able to enrich it in the most efficient way, or the most healthy way, or the most best way, whatever. So this information that I need here is inventory information, so I have to connect to the inventory somehow. So maybe we connect to the inventory process and not to the backend. But that's that's my plan somehow. So far, I put my grok patterns that I used on GitHub. So for SLURM and for OpenSM and for all that kind. And I did a test framework in Python once, which was pretty ugly because you have to reinstall or install Ruby and install the grok library, and this was pretty painful. So now I use Go, so the Go library of grok, and I create little tests. So here's one test. So I know if you use grok, but grok is basically variables over regex, and you can use this regex variables in another regex, so you can have very easy readable regular expressions. And I define the regular expression I want to check. I define an input and I define a result, and my Go Timberchop library then uses this tests to verify if the patterns are correct or not, because this is something that I messed up all the time. So I create a pattern, then I think it was okay, I thought it was okay, I put it somewhere and then it didn't work, so I would like to have an infrastructure where I can test and verify that my grok patterns are correct. So this is one way of testing it. So I have a test for each pattern file, and this is the basic idea behind the grok infrastructure. And with this I would like to create little Go binaries to refine only the grok patterns that are in on the host. So if I have a container, then the application should create patterns into the etc grok pattern path, and create a refinement. So the grok configuration or the log configuration for this particular application as well in a predefined path, and then you start my, I don't know, I don't have a name yet, but let's call it glog or something. It will pick up the configuration out of the path, and then you only have the configuration that you need for this local service, and then it will forward it to Fluent, and hopefully also refine data from different other resources. That's the plan. And as to be able to scale it to more nodes. So if I have 1,000 node and one Logstash instance, and I don't pre-format or pre-refine the logs before I send it to Logstash, then Logstash will burn, and I only send stupid logs maybe. So you want to have an instance that scales up with your horizontal outscaling infrastructure, right? So you want to have it local, the most logic local, and only the information or the logic that is necessary on a global level should stay on a global level. So if the Logstash server then says, okay, I see 15 nodes are burning, then I maybe issue some action. It's better than I have first to figure out that 15 nodes are burning, and then I can act on it. So having a small daemon in front of the local server, I think what I would like to do someday. Okay. Yeah, for a filler, it's half an hour. Maybe it's a little bit long, but yeah. So that's what I would like to point out. Questions or applause? Maybe applause is good.